This is P1 matter, density and pressure. I have one cube made of wood and I have one cube made of lead. Now if I'm looking at the bottom part of the cube, the one that's sitting on the table, well, I see that both for lead and for wood and lead, that area, the surface is exactly the same. So they're sitting with the same surface on the desk. Now if I'm looking at the particles inside the lead, there are much more particles in the lead compared to the wood. That makes the lead a much heavier substance for the same size for that cube than the wood is. Now, if I'm looking at the formula for density, density equals mass over volume. If both volumes are the same, the one that will have a bigger mass will have a higher density. Well, in this situation, I'm looking at lead. I see there are a lot of dots there. That means there are a lot of particles in that cube. Lead must have a bigger mass than wood has. That means density for lead is mass over volume compared to the one for wood, mass over volume, which makes density of lead much higher than density of wood. Now, if it has a higher density, that means it's a heavier object. For that means the cube on the right will be heavier than the cube on the left. Now, if the cube on the right is heavier than the one on the left, the cube on the right, like the lead, will put more pressure on that specific surface, the one that touches the desk, compared to the same surface for the wood. That means the pressure for lead is higher than the pressure for wood. We can say that for objects the same size, the one that has a higher density will also have a higher pressure and will weigh more. That means we'll have a higher weight. Now, if I'm looking at how do we define density? Well, density is mass over volume. Mass, pretty much how many dots, how many particles are the amount of particles in the substance, and the volume is how big or how small something is. In this case, we're looking at the space, the volume that something takes. So if there are many dots in a small volume, that means the substance has a big density. The pressure is I just put it like this, a bit non-physics wording, is the push on the ground. If I look here, the wood pushes less on the ground than the lead because there are less particles in the wood compared to the particles in the lead. And the weight is analyzing how strongly the earth pulls something down. Now, if you have a lot of particles compared to the like lead is heavier than the wood, that means lead will be pulled down to the earth stronger than the wood is. So again, higher density means higher pressure, means higher weight. Moving to the right side of the diagram of the picture, I have a cube, A1. We have a cube, and then the shaded red area is the area that the cube is sitting on the desk with. And then we have a cuboid, A2, and then we can see that the area of the cuboid is much larger than the area of the cube, the A1. That means the cuboid, so the volume of the cube we calculated by side times side times side, which is because the cube has the same size, which will be just L to the third. That means the same side. But the cuboid, because they're not the same, the sides of the cuboid, I will just say width times length times height. We can take any one of these as the width, as the length, as the height. It doesn't matter. The result will always be the same. Now, if the masses of these two, of the cube and the cuboid, are the same, so the mass of the cube is 1 kilogram, the same as the mass of the cuboid. Now, if I'm looking at the definition for pressure, pressure equals force over area equals weight over area. Now, for the same mass, that means the one that has less area will have a higher pressure. So that means the cube, because the cube is standing on the desk with a lower on the lower area, the area of the cube is smaller than the area of the cuboid, 1 versus 2. That means the pressure of the cube will be larger than the pressure of the cuboid on that specific desk. This is, I consider, like you're wearing high heels or you're wearing flat soles. The difference is there. Now, if we have the states of matter, As I look at the solid, there are lots of dots in a solid. That means there are a lot of particles in a solid substance. If I'm adding heat, I'm heating up solid. The solid will become a liquid, which means the particles will spread out a little bit. That will be less particles in that specific area. And then if I'm adding more heat, it will become gas. And in gas, we know that the particles just move away wherever they can. The density of the solid is larger than the density of the liquid is larger than the density of a gas. Thank you.